Now, this one, of course, the second one, it involves integral, which kills a lot of you. But I believe you should know how to do it. Okay. We give you a force. Depends on the time. Okay. So F equals to F naught sine omega t. Okay. And so, of course, you should know acceleration. So for this problem, I think, it's one thing surprised me is that many of you don't even get the partial gradient. Okay, even you cannot do the integral correctly. There's something you should know what's going on here. For example, acceleration, you should know how to express it, right? It's just divided by mass, the force divided by mass, right? So that's the acceleration function. Once you have the acceleration function, what is v? It's just an integral. In general, it's an integral of acceleration function. So, right? And the position function is just the integral of velocity function. Once you get the velocity function, right? We first write it a dt, v dt. Okay. In fact, if you write on these things, 3 points. Okay. So I'm not thinking about the actual calculation number. As I said, I always get wrong number. So, okay. So let's see how can we integrate it. If we want to integrate it, this is f naught over m integrate with sine omega t, right? dt. So let's do the integral here. If you want to integrate that, so you will get the integration of sine function. What's that? Negative cosine. Okay. So you get negative here and cosine here omega t. But you are integrated with omega t. This is the argument is omega t, but integrate with dt. So it will be, you need to get one omega here, right? That's the integration. If you are not sure about, you can take the derivative back to check it. If you take the derivative back, you will redouble that. But this is an indefinite integral, so it has some arbitrary constant. We have to be able to fix the constant by thinking about, so if this is the general expression, so we need to check that when t equals to 0, okay? Oh, sorry, this is velocity function, okay? When t equals to 0, according to this, the velocity equals to negative f naught divided by all m omega. Okay, cosine 0 equals to 1 plus c. But thus, when t equals to 0, this must be equal to v naught, the initial velocity given, right? So that indicates c is actually v naught, f naught divided by m omega plus v naught, right? So velocity actually should be written as negative f naught m omega cosine omega t plus c, which is f naught m omega plus v naught. So that's your velocity function. And then you put the velocity function to here, you do the integral to get the x function. Okay, so x equals to this. So negative f naught m omega integral of cosine omega t and integral of this okay. So you will see that the first term, what is the integral of cosine? It's sine, but you still have this negative side here, okay? So you get negative f naught divided by m omega sine omega t. But again, when you integrate with t, you have some omega here. So f naught divided by m omega squared. So that's the first term. The second term is simple. It's just f naught m omega t, right? Integral is a constant. And this is v naught t plus c prime, another arbitrary constant. And to verify this, c prime is very simple. When t equals to 0, let's look at from this equation, x equals to c prime, right? All these terms vanishes when t equals to 0. But this should give you the initial position. So c prime is actually the initial position. So x, if you combine this, is x equals to negative f naught m omega squared sine omega t plus f naught m omega t plus v naught t plus x naught. Okay, so that's the right answer. It looks a little bit long, but it's quite straightforward because all these are elementary functions, sine, cosine. Okay, I'm pretty sure you are right now you are doing much more complicated integral. Okay, calculus 2. Right now you are learning technique of integral, which is beyond this elementary function, right? But we're not going to use those things, but this fundamental calculus, you have to know how to use them. Okay, because that's a very important thing. The best way to understand physics is to think about from the calculus point of view. Okay, it unifies many seemingly separate topics together with the integral. Okay, how can you get this velocity and position function from the Newton's second law? Okay,